130 years have passed since we started being able to see inside the human body. But at the beginning, great technologies almost always pose great risks to users as well. So how did X-ray technology go from dangerous radioactive and chemical hazard to safe and fast technology we have today? In this episode of Pyxis Product Focus, we are covering X-ray technology, specifically X-ray printers and films. We will talk about evolution of X-ray printing and the industry that made it all possible. X-rays were discovered by Wilhelm Roentgen in 1895 in Germany. This was revolutionary back then. For the first time in human history, we could see inside the human body without needing surgery. Back then, using glass plates was standard for recording any types of light. So Roentgen used these glass plates to capture X-ray images. In fact, it was the glass plates that led to his understanding of what these X-rays were capable of. In the late 1895, Roentgen was experimenting with cathode rays. These experiments involved discharge tubes powered by high voltage electricity. On the evening of November 8, Roentgen was testing whether cathode rays could pass through glass or other materials. To block visible light from the glowing tube and avoid interference, he carefully covered the tube with thick black cardboard. While running the experiment in a dark room, he noticed faint greenish glow appeared on a small screen coated with fluorescent material that was sitting nearby on his workbench. But this was surprising because this material was about 1-2 meters away from his workbench, and the tube was completely covered with black cardboard, so the light could not escape. He realized this glow must be caused by some new invisible rays coming from the tube that could penetrate the cardboard shielding. He immediately started testing to figure out what these mysterious rays could be. He quickly found out that rays could pass through most materials, such as paper, wood, cloth, and some metal sheets, but it was being blocked by denser materials. Roentgen spent the next 7 weeks investigating this phenomenon alone in his lab, barely sleeping or leaving. He documented every detail he learned. Jesus Christ, 7 weeks. Bro was locked in. The famous breakthrough came on December 22, 1895, when he used photographic plate instead of fluorescent screen. He asked his wife Anna Bertha to place her hand in a path of rays for about 15-minute exposure. The resulting image showed the bones of her hand clearly, along with 2 rings on her fingers. This was the first medical X-ray image in the world. He called this X-rays because the rays were mysterious and unknown. This discovery led him to receive first ever Nobel Prize for Physics in 1901. Siemens was the first company that made X-ray generating tubes and devices, but Kodak was the one supplying the glass plates for the early X-ray image recording. These glass plates were coated with light-sensitive emulsion, such as silver halide crystals. X-rays hitting these crystals changed their state, creating the image. But as you might guess, handling glass plates were very challenging for healthcare professionals. Innovation was needed to solve many of the shortcomings of this technology. This innovation for X-ray plates came from the photography industry and solved many of its cons, such as fragility, weight, and cost. In 1918, George Eastman, founder of Kodak, introduced improved X-ray film that was more practical for medical use. It was a flexible, transparent material that could be coated with photographic emulsion. This, of course, improved many negative aspects of using X-ray glass plates, though the most important flaw of the technology remained: toxic chemical processing. Taking the X-ray image was not the only procedure needed to see what was wrong with someone's organs. After exposure to X-rays, the films had to go through a 5-step development procedure that was time-consuming and complex. First, the films had to take a chemical bath containing hydroquinone and metal for quick image emergence, along with alkali to maintain a high pH. Temperature had to be precisely controlled during these procedures, otherwise the image quality would suffer. After this first step, a stop bath had to be done to prevent the fixer from being neutralized too rapidly. Third, the fixing solution needed to remove unexposed silver halide crystals. Soaking the films in these chemical solutions required washing so the films could be handled safely by medical experts. If not done properly, the films would deteriorate over time. As a last step, the films had to be dried before use. It is important to mention that most of these chemicals used in these procedures were toxic, and healthcare professionals suffered for many years as a result. Thus, the whole procedure was not only inefficient due to the use of dark rooms and multi-step process, but also dangerous for people handling the printing procedure. Innovators, of course, were looking for a better technology to replace this chemical-intensive procedure. The required solution that solved every disadvantage of previous wet film processing arrived in mid-1980s. This was the third and most important evolution of this technology. Fujifilm developed the dry pick system, which used special thermally sensitive film. Heat from a thermal printer head created the image. No darkrooms, no chemicals needed. Other companies such as GE Healthcare, Siemens, Canon, Aqua, and Carestream, formerly Kodak, followed suit. Starting in the early 2000s, this technology rapidly replaced the old inefficient wet film processing. Ironically though, Kodak, which had led the two of the previous evolution of X-ray films, was slow to implement the new digital films. They struggled in the early 2000s and 2007. Their healthcare division became Carestream Health. Today, the X-ray film market is declining due to the rise of digital images. However, it is still relevant, valued around $1 billion between 2024 and 2025. Fujifilm, Aqua, and Konica dominate the market with 60% market share. The rest of the market is divided between the other players such as Carestream and Sony. The most popular printer Fuji offers is DryPic Smart. It's a compact tabletop model with up to 80 films per hour output. Another model is DryPix Plus for high output printing, supporting 160 films per hour. It can also accommodate 3 different drawers for different size films. Aqua has similar models such as DryStar 5302 and Axis, spelled as AXYS. The former being higher density for mammography and general radiology. Their competition with Fujifilm is a close one. Both brands offer different types of films with different sizes. Fujifilm have 2 main film models, DI-HD and DI-HL, and Aqua has DT2B and DT5B. The first one being for general use and the second is premium, thicker version. But there's a problem with these films. One of the interesting mechanisms in the industry is the implementation of chips on the films. Just like some inkjet printers use chips to lock users into their expensive ink cartridges, X-ray printer companies use the same strategy. Though this is a bit different from consumer printer industry, where companies like HP sell printers cheap and make profit from expensive ink cartridges, X-ray printers on the other hand are not cheap at all and are priced between $10,000 and $40,000. By placing a chip on the X-ray films, they can make even more money. Chinese manufacturers are, of course, solving this problem too by copying or licensing these chips to offer cheaper films to the market. Their printers are good too, with almost identical quality at a lower cost. I believe that no matter how much digitization happens in the industry, there will still be demand for physical printed X-ray films, just like with paper printing. The industry has matured by completely getting rid of any toxic and environmentally damaging procedures from the imaging system. And while the market certainly will not get bigger, its shrinkage has also plateaued. New Chinese manufacturers are slowly filling the gaps in the market by making cheaper printers and film alternatives for developing markets, making this amazing technology accessible to all. I'm also playing a small role in this process by connecting international hospitals, medical product and equipment distributors to these Chinese manufacturers. The nature of my business requires me to learn every detail about the product's history and technical specifications. I just wanted to share what I've learned from my experience over the years with you. I hope it was helpful. In our company, Pyxis Product Sourcing, we connect our customers to Chinese manufacturers and help them to find, inspect and ship the goods. If you ever need medical products, X-ray printers or films, we can find them for you. Contact us and tell us what you need. Please consider supporting the channel by following and turning on notifications. In our next episodes, we will be covering more medical and industrial products. Thanks for watching. See you in the next one.